What does it mean to deploy a machine learning model? The phrase machine learning models in production can mean anything from a batch scoring job that runs weekly to computer vision models in a self-driving car that make predictions in real time. Many businesses might think that they don't have a real need for real-time machine learning models. Or they might have experimented with deploying machine learning models in the old school REST endpoint method and found it too difficult to manage and scale while simultaneously tracking model performance. In this demonstration, I'm going to show you how you can deploy a machine learning model as a table inside of our database and use that table to power a dashboard that shows the predictions the model is making in real time. First, what is Splice Machine? Splice Machine is a data science platform built upon a hybrid database. The database itself can perform both transactional and analytic queries, while the machine learning platform incorporates popular open source tools like Jupyter Notebooks and MLflow. Moreover, we can easily integrate with other ModelOps environments if you choose to build a model outside of Splice Machine. Splice Machine is currently being used in applications ranging from petabyte scale, mission critical enterprise applications to smaller use cases at startups. Now, let's go ahead and build our real-time dashboard. First, we will begin with a trained machine learning model that we have logged in MLflow. The model can be trained in the Splice Machine platform or easily imported from wherever you have trained your model. In this case, we have a model that predicts fraudulent activity in credit card transactions. Now we deploy this model as a table inside of the database. What does this mean exactly? We create an empty table inside the database that has a set of database functions and triggers associated with it. Whenever a new row of features is added to this table, the result of your machine learning model is automatically generated and stored in that same database table, along with some metadata. Here at Splice Machine, we are thrilled to see the general idea of deploying models as tables inside of a database really taking off. There are now several database vendors, as well as startups, offering some version of database deployment. But database deployment, as we define it, is much more robust than anything else available on the market. You don't, for example, have to train your model inside of the database using custom functions. Any arbitrary scikit-learn, Keras, SparkML, or H2O model trained inside or outside of the Splice Machine platform can be deployed as a table. Additionally, because Splice Machine has a transactional, ACID-compliant engine capable of handling millions of simultaneous operations, you can power real-time applications with our database deployment. Now, how does it work exactly? Creating a database deployment table is as simple as calling our deploy_db function and specifying the table you want to create, the MLflow run ID associated with your trained model, as well as the features the model expects to see. The table inside the database, as well as any relevant functions and triggers, are then created for you automatically. Generating a prediction is as simple as an insert statement in SQL. Now, let's see how this can be used in real time. Splice Machine has the Apache Nifi platform built in. In just a few minutes, you can build a flow that consumes a real-time data stream. In this case, we are using Kafka. Convert that data into SQL statements and insert it into the deployment table we created before. Here, I simulate a Kafka stream of data, and Nifi takes care of the rest. The real power of database deployment is the unprecedented levels of data governance it gives you. For example, you can easily monitor the predictions that your model is making in real time. The open source dashboarding tool, Grafana, is embedded in the Splice Machine system. In this case, the predictions that the model is making, as well as select features feeding into that model, are refreshed every 5 seconds. Building a dashboard like this is very straightforward. You just write SQL to query the deployment table. Finally, because features and predictions are persisted in one scalable location, you can easily look backwards to analyze model performance, use predictions as features in other models, or build retraining pipelines. Thanks for watching, and please reach out to a member of the Splice Machine team if you want to learn more.